Summation example. Prove for a positive integer n, 1 over 2 plus 2 over 2 to the 2 plus 3 over 2 to the 3 plus 4 over 2 to the 4 plus up to n over 2 to the n is equal to 2 minus n plus 2 divided by 2 to the n. Okay, so we're going to use a trick to get to the left-hand side of this equality and to prove it. And to do that, let's define a function f of x such that f of x is 1 over x plus 1 over x squared plus 1 over x cubed plus 1 over x to the 4 and so on plus 1 over x to the power n. This is effectively sigma k from 1 to n 1 over x to the k, or you can rewrite it as sigma k from 1 to the n x to the minus k. With this function, the interesting thing is it is a finite geometric summation because it starts with the initial term 1 over x, and then each term is just need to be multiplied by 1 over x as the common ratio to get to the next term. So 1 over x squared is just 1 over x multiplied by the first term, and 1 over x cubed is just 1 over x again multiplied by the previous term, and so on. So we can say f of x is a geometric summation with initial term which we name it as t1 as 1 over x. We can say with common ratio which we name it as r equal to again 1 over x, and lastly with final term which we denote as t of n is, or tn is equal to 1 over x to the n as shown here. It is a well-known summation, and we know we can write f of x is equal to first term minus common ratio times final term divided by 1 minus common ratio. Knowing that common ratio is a number less than 1, we are making the assumption that x is just greater than 1. So with this in mind, let's just substitute. It becomes 1 over x minus 1 over x times 1 over x to the n divided by 1 minus 1 over x. So if you rewrite, then from here we get f of x is just 1 minus x to the minus n and divide by x minus 1, which is this summation here. So I'm going to rewrite that summation again, sigma from k equal to 1 to n x to the minus k. Okay, so this is an important equation for us. Now I'm going to use this, and I'm going to take the derivative of f of x with respect to x. So I can write derivative of f with respect to x is equal to, on this side it's simple, sigma k from 1 to n minus k x to the minus k minus 1. On this side it's going to be derivative of the numerator times denominator minus derivative of the denominator times numerator divided by denominator square. So we have n times x minus n minus 1 times x minus 1, that's denominator, minus derivative of denominator, which is 1 times numerator, so it's 1 minus x minus 1 n, and denominator squared. Okay, so what I'm going to do is I'm going to now find out the value of this derivative specifically at x equal to 2. So in this case I'm going to factor out 1 over x from this whole thing, and I'm going to factor out negative sign, so it becomes minus 1 over x sigma k from 1 to n, k over x to the k is equal to, on this side I have n, 2 to the negative n minus 1 times 2 minus 1 minus 1 minus 2 to the minus n, divide by 2 minus 1 to the 2. Okay, simplifying this side, I have 2 minus 1 but to the 2 is just 1, so denominator is 1. That leaves us the numerator, which is just simply n over 2 to the n plus 1, minus 1 plus 1 over 2 to the n. Okay, so interestingly, what matters to me is this portion is exactly the left hand side of the equation that I wanted to prove. You can see that with x equal to 2, we get exactly to that one. So this is with x equal to 2. So what I get is minus 1 over 2 sigma k 1 to n k 2 to the k, which is exactly the portion, the left hand side of the equation that I wanted to prove, is equal to this side, which is n divided by 2 to the n plus 1 minus 1 plus 1 over 2 to the n. Multiplying both sides by negative 2, I get sigma k from 1 to n k divided by 2 to the k equal to 2 minus n divided by 2n, 2 to the n, and then minus 1 over 2 to the n minus 1. Further simplifying this, we can get 2 minus n plus 2 divided by 2 to the n, which is exactly what we wanted to prove. So we proved it, and one interesting outcome is limit of sigma k from 1 to n k over 2k when n goes to infinity is equal to sigma k from 1 to infinity k over 2 to the k is going to approach, this thing goes to 0, so 2. That's also an interesting conclusion.